Kalcharan from KS Institute for Engineering Technology. This video is about our final year project, and what our project it is adaptive battery management system for efficient integration of bifacial PV and GaN power converters. Here what are you looking at, it is a fully functional working prototype of our adaptive battery management system designed and built as for our final year project at KSRIUT. Every components on this board is connected, powered and working in real time. The next 5 minutes we will talk you through exactly what it is the system does, components. And first we go to the voltage regulator. The voltage regulator supplying stable 3.3 volt and 5 volt to all control electronics. The temperature sensor, it will monitor the battery thermal condition, and then it will, based on the temperature level, it will control the battery charging and discharging levels. And the current sensor measuring real-time charging and discharging the current through the measuring of input and outputs. This is the ESP32 module, the central controller of our adaptive BMS. It operates at 3.3 volt and features a dual core processor capable of high-speed real-time data processing. The ESP32 is continuously running our adaptive control algorithm. It reads voltage, current and temperature values from the sensors every second. Based on those readings, it calculates the state of charge and state of health of the battery in real time. It also runs the self-balancing logic, deciding when to activate or deactivate balancing circuit based on the voltage difference between cells. And also, if any parameters goes outside the safe range, over voltage or over current or overheating, the ESP32 immediately triggers the relay module and then cut off the charging or discharging to the circuit. Without this module, none of the adaptive intelligence in this system would be possible. And then here we will see the A2C module. It will all the sensors in the system, voltage dividers, current sensors and the temperature sensors produces only analog signals into the previous digital values that the ESP32 can process. It communicate with the ESP32 using it to wire through the I2C protocol, which you can trace in the collared wiring harness. This high resolution conversion directly improves the accuracy of our SOS estimation and the fault detection also. And this small board on the right side is our current sensor. It is connected in series with the battery pack, measuring the real-time data current flowing in and out during charging and discharging. It produces an analog output signal proportional to the current. This goes directly to the A2C module for destination. The ESP32 uses this real-time current data to calculate the power, estimate the exposure and detect over current or short circuit current conditions. That's the uses of the current sensor. Now we come to this board, variable potentiometer board. It allows us to simulate different levels of PV input, mimicking the irradiance conditions from 200 to 1000 watts per square meter. This is how we tested our system response across varying solar conditions during our experiments. First, we go for in the voltage regulator. Voltage regulator supplies stable 3.3 volt and 5 volt to all the control electronics in the center top. The ESP32 microcontroller, which is the brain of the entire system, and then the charge controller managing power flow between the PV input through input and to the batteries, and then the LCD display. It's showing live battery data below center the ADC module, converting analog sensors signals to digital, and then variable potentiometer used to simulate different PV input levels, bottom right, and then temperature sensor. This will be then now we are going to the charge control circuit. It will simulate the PV input and battery pack. It works together within the ESP32 to regulate the charging in real time based on the current SOC and the irradiance conditions. And the relay modules. This board on the top right is the voltage regulator. The input to our system comes at a higher voltage. This regulates step it down to the stable 5 volt and 3.3 volt advised by the LCD ESP32 and the sensors. Without stable power supply, sensor readings comes noisily. The ESP32 behaves unpredictably and the entire system fails. This regulator ensures the clean regulator power to the every control components regardless of fluctuations in the input source. This is our complete adaptive battery management system, fully assembled and functional. Every component works together. The ESP32 thinks, the sensor measures, and the ADC converters, the relay switch, and the LCD displays, and the charge controller manage power, all in real time, all adaptively. We tested these systems across simulated irradiance conditions from 200 to 1000 watts per square meter. The results show 22.7% higher energy yield, 28% lower power loss, and the 88% capacity retention, all validated statistically with a p less than the 0.001%. So thank you.